Codemotion.
Thank you for coming. My name is Patrycja Wegrzynowicz, and today I'm going to tell you about performance anti-patterns in Hibernate. First, briefly about me. I've been doing professional software development for nearly 15 years. I still am active developer, and I must say I love it. Also, I've been doing my PhD, and my research interests focus on patterns and anti-patterns in software, along with static and dynamic analysis to detect various issues in software. Most recently, I founded Unita, which is a California-based startup focused on the tools for automated detection and refactoring of various bugs in software. So basically, corner cases and anti-patterns are my daily job. Today, I'm going to show you 4 puzzles. A puzzle is a short program with curious behavior. I will have questions for you, so don't be shy and raise your hands when asked. Then we will have 7 performance patterns with short descriptions, consequences, and possible solutions to them. Okay, first disclaimer. As I've been talking about Hibernate for several years already, and people often think that I'm bashing Hibernate. That's not the case. I do think Hibernate is a great tool. First of all, it increases our productivity. It facilitates our work. Hibernate does all those nasty and tedious stuff for us. Last but not least, Hibernate is free, right? And software is like sex. It's better when it's free. Do you know who said this? Another disclaimer, it's not me. It was Linus Torvalds, the author of Linux, that operating system. So anyway, I've been doing programming with Hibernate for a lot of years. And very often I'm pretty puzzled. I'm getting annoyed, and on occasions, I'm getting really pissed off. Anyone here who shared such experience with me? No one? Please? Yes. But not so many of you. Okay, so let's start the talk. The first puzzle is not exactly performance puzzle, but I would like to show you for several reasons, also to learn some performance lessons from it. And before we start, the question to you, who knows caveat emptor application? Yep. Okay, only one hand raised, not so many. So who's read Java persistence with Hibernate? Yep, that's the Bible of every Hibernate developer. And caveat emptor is a demo application that comes with the book, right? So it should be a good source of best practices and patterns, right? So let's take a look at the heart of the demo. This is place bit action, because this is a simple auction. Caveat emptor is a simple auction system. So the most important action is to place a new bid for a given auction, right? So we have here the piece of code. It's invoked in a transaction. So the transaction begins at the beginning of the method and ends at the end of the method. We have very simple code. We just get minimum and maximum bid from the underlying database, and then we find the given auction and pass the maximum and minimum bid to the business method, which actually checks business conditions and modifies the auction properly, or throws an exception if something goes wrong. Do you see any problem here? Maybe there's no problem. So the puzzle for you, 4 answers. The first, that the code is correct. that one is obviously wrong. Otherwise, I wouldn't be speaking about this, right? So the second one, that there are some problems with transaction and clock management. Maybe some exception thrown. With Hibernate, you never know. And the safe answer, because you never know what you get with Hibernate, right? Okay, so who goes for A? No one, you're smart. Who goes for B? Only one, got two of you. Yep. What about C? A few of you. Looks like a quite popular answer, and D, safe choice. So, the correct answer is transaction clock management. So, actually, this piece of code is incorrect. So, congratulations to those of you who found out the right answer. The bits can change between calling getMaximumBit and locking the item. Take a look here. This is the place that the actual modification can take place. Actually, it depends on the actual context switching between various threads. So you can run into this issue late in the production. But nevertheless, it can happen. Let's take a look at the actual scenario under which this can happen. So let's assume we have 2 bits and 2 users bidding for one item. And there are already 2 bits for the given item in the database. So the first user bids with a new value 100, and the second user bids with the new amount 30. So thread 8 represents the first user with amount 100, and take a look at the current maximum value after we execute getMaximumBit. It's 20, it's correct, and in this very moment we switch to another thread, and this second thread retrieves exactly the same current maximum number, which is 20. And you can see now the scenario that the first user successfully bids for the given item, and unfortunately, the second user also successfully bids for the item with the lower amount. So something's wrong here, right? Do you have any idea how to fix it? Any ideas? No, come on. Okay, I will give you some hints. Version and optimistic locking. Does it work? What do you think? You think it works? Unfortunately, this time you are wrong. It doesn't work. The scenario is exactly the same. Because you release the item and increase the version, and then you switch to the second thread. So the second thread can obtain completely like fresh version. So it doesn't work, unfortunately. We can switch to repeatable reads isolation level, because the default isolation level is much lower. Is lower. So does repeatable reads work? What do you think? Unfortunately, no. We can also switch to serializable isolation level, which basically means that the whole program is executed like in a single threaded model. It's approximation, but more or less it's like this. So serializable mode works fine and gives us correct code, but slows down the application. That's the problem. We can change the sequence of our lines and move vlog before get minimum and get maximum bit, and this is a correct solution. And basically, it's like a manual log management, and it works fine. Because however, we must be very careful, because it works fine if in our entire code base that touches item, the sequence of log acquiring is exactly the same. So first we acquire the log for the item. Okay. Different object model. We can think out about different object models, like using of item list, and instead of selecting minimum and maximum bit, we can keep track of maximum bit in our business model. This would work much better, and it would work fine with such logging schema. We can come up with other object models as well. So yes, this is a good approach to think about different object model. Another idea is to use Java synchronized proc, and it works fine unless you don't have a distributed environment like many servers to load to balance your load or something like this. So in Java synchronized works only for a single JVM, and it's basically like a single-threaded model for this piece of code as well. Okay, so lessons learned here. Nobody's perfect. Even big names make mistakes, as you could see in the piece of code. ACID is only a theory, and for real-world application, often you need much more complex transaction management. And the first anti-pattern, because if you've read the book carefully, you've learned why the authors designed this piece of code this way. Because they thought that would be much more efficient, like to perform aggregate query directly on the database instead of iterating and calculating the maximum bit in memory or applying a different schema, object model design. So premature optimization is the root of the evil. Keep this in mind. And performance lessons learned here. With Hibernate, we must design our object models very carefully, because this is the primary factor that impacts the performance of your applications. Then, designing your object models, you need to take into account various usage patterns, like the number of concurrent users, like data volume, and according to these factors, plan your object model along with transaction and log management. Because when your application does not need high-level concurrency or does not operate on huge data volumes, you can go for a simpler solution, which is less performant, right? But guarantee correctness, which is the most important requirement in your applications. Okay, another puzzle, which is called Heads of Hydra. Okay, Hydra is this mythical creature which is supposed to regrow 3 heads in place of 1 head cut off, right? Oops, sorry, a short break. Okay, so apologies for the problem, and let's go back to our puzzle. Okay, so we've got this Hydra, which is supposed to regrow 3 heads in place of 1 head cut off. So when we model our entity to be Hydra, we want to guarantee some properties, like this regrowing, right? So we have a business method, cut the head off, which manipulates on the list of heads. And we have getHeads method, which returns the list of heads. And we want to guarantee that no one changes this list. That's why we return unmodifiable list, right? We just want some consistency and encapsulation here. So we don't want to return modifiable lists for no one to modify lists without the permission of the Hydra class itself. And what happens when we, in the first transaction, create and persist the Hydra with 3 heads, and in the second transaction, in completely new entity manager and completely new transaction, we just retrieve our Hydra object. How many queries are performed in the second transaction? It seems that the answer is obvious, like one select. One select because we select the Hydra object itself, and because the default is that collections in Hibernate are lazy loaded, so there is no second query. So it seems that the answer A is the obvious answer. But you've already learned that I want to trick you. So now we'll see whether or not I managed to trick you. So who thinks the right answer is A? Raise your hands, please. Quite many of you, I would say like 5 people think so. What about B? Also popular, like 6 or 7 even. What about C, 1 plus 3? So you think that there is a single select for each head, right? Okay. What about D? That seems ridiculous, but there is one guy who thinks it's D. What about E? Safe choice. Remember this. No one. Okay, so we have the winner. The answer is D. Why? This is pretty tricky because we've performed only read-only operation, right? But during commit, Hibernate checks whether the collection property is dirty by comparing Java identities. And let's take a look at our class again. And you see that we've used property access mapping, right? That our mappings are on the property level, not the field level. So while comparing whether something changed in the collection, Hibernate checks the collection returned by getHead, which returns a new object, new Java object, wrapped original collection, wrapped into unmodifiable collection. And then Hibernate decides that's completely different collection and goes for another solution, like recreating the whole collection. So it deletes all Hydra heads and then inserts new old heads, actually. So that's why we have 1 delete and 3 inserts. How can we fix it? The fix is pretty simple. I would advise you to change the field access mapping. So instead of mapping on property level, go for mappings on the field level. Lessons learned here? Expect unexpected with Hibernate. And definitely preferred field access mappings. Yep? Yes, sure.
Yeah. Should we prefer always a field access mapping instead of a property mapping?
My answer, short answer would be yes. The long answer, it depends on the situation, and we could go into some very specific cases where property access mapping is better. But those, according to me, are very, very rare. In general, go for field access mapping because usually you want to have some validations and there are much more trickier puzzles when it comes to combination of the property access mapping and business validation in your getters and setters. The second anti-pattern is lost collection proxy on owning side. Because on the owning side, when you retrieve the object from the database, you get a wrapper, a Hibernate wrapper that wraps your collection. And the problem here was that we lost this actual wrapper, Hibernate wrapper returned by Hibernate. So Hibernate could not track our changes in the collection, and then it decided to recreate it. So this was a pretty tricky case, but we can take a look at much more simpler case, which happens very often in real-world applications. Then we expose setter, and this setter can change collection. So even though the elements in the collection are the same, the Hibernate decides to change the whole collection in the database. So a few hints for you to operate on collection objects returned by Hibernate, unless you know what you're doing, because again, there are some special cases in which it might be more performance-wise to recreate the entire collection. But again, in such cases, I think that Hibernate could do much better and apply much more smarter policy. The third puzzle, it's called Fashionable Developer. Have you ever heard the talk by Ivar Jakobson? So he says that software industry is very fashion-oriented industry. And basically that's true. Think about yourself. We always go for new technologies, new things. We want to evaluate them. We want to use them. We need more challenges in our work, right? So here we have such a developer. This is a single entity with two basic fields, ID and main technology. And this developer wants to evaluate new technologies like HTML5, Android, and Scala. So basically, the code iterates over these three technologies, and we set new main technology to the developer, and then we check out how many others are using it and whether or not the developer himself likes it. In the end, he decides that he doesn't like them and goes back to the original technology. Now the question for you, how many queries in our second transaction? The first one is just to create a developer that uses Hibernate. So let's do a very quick analysis. It seems that we have like one select to get developer, and then we have 3 selects in every loop, right? One select in every loop, so in total 3 additional selects. So it would be B, 4 selects. What do you think? Who thinks it's A? Only 2 selects. Maybe Hibernate can optimize such tricky cases and do only 1 select for this internal aggregate function like counting. Who thinks that Hibernate is so smart? Oh, no one? I'm disappointed. What about B? 4 selects. Yep. There is the guy who still believes me. Can you imagine this? I'm flattered. Thank you. What about C? 4 selects and 1 update. Just to update and the end. D, 4 selects and 4 updates. Why? Why do you think so? Okay. Basically, okay, basically you're right. So we've got another winner for our puzzle. Yes, 4 selects or 4 inserts. Hibernate must guarantee correctness of executed queries in terms of all the modifications. So we introduced like temporary modification to our model, changing the main technology of the developer. So that's why when we execute a query that operates on the same table, Hibernate must refresh the model, so flash all the changes, and then it can execute the select. 4 selects, because take a look. We have 1 select for developer. Then we have select here. But before the select, Hibernate must perform flash. So that's why it's 1 update and 1 select. The flash is because developer has a new technology, and this query touches the same table. So even though it doesn't touch the same rows, only the table. Take a look that this developer is not taken into the account in this query. So, but nevertheless, Hibernate must flash its state to the database. That's 1 update, and then select. So here we have 3 selects and 3 updates, and the 4th update is in the end. What happens when we comment out this nasty select? You can see no updates at all, even though the value of the main technology has been changing during the execution of the piece of code. So the third anti-pattern is temporal changes. We need to be very careful with temporal changes because flash can happen at any moment. If you modify your code, it may mean for Hibernate, it may change Hibernate semantics. Okay, the 4th puzzle, plant a tree. This is very simple. This is a basic one-to-many mapping with all the defaults, right? One forest with many trees in a collection. In the first transaction, we created persistent forest with 10,000 trees. And in the second transaction, we want to plant a new tree. How many queries in the second transaction? 1 select, 2 inserts. It looks like too little, like for performance problem, right? So B, 2 selects, 2 inserts, or maybe C, D. What do you think, guys? Who goes for A? No one. Who thinks it's B? No, it's C, maybe. There are a few hands out.
It depends on what plant tree does.
You see, it simply adds to the collection. So, nothing fancy. So, do you go for D? For C? So, D. In this case, it was C. The problem is here that the combination of one-to-many and collection doubles back semantic. And back semantic means that the whole collection is recreated. So Hibernate deletes it, and then inserts the entire collection once again. Pretty inefficient. Don't you think so? So we want to change this piece of code to make it more efficient. So probably when we use lists, it will be more efficient. What do you think, guys? Is it going to be more efficient with collection change to list? Unfortunately, no. Still back semantic. Why? Why back semantic? Because we should use order column or index column for list semantic here. So be very careful, because I've seen many of these in real-world code. I guess that you've seen this as well. So one-to-many without order column or index column means simply that you, every time you recreate your collections. Pretty stupid. So here you've got some hints for how to combine Java type and annotation to achieve different semantics. You see that the problem is with back semantic and list semantic, which is pretty unobvious. Because to achieve list semantic, you need to, in addition to Java type list, you need to use another annotation. So that's pretty tricky. And the different semantics mean different performance in terms of addition or removal elements from your collection. For a single element with back semantic, you get basically recreation. Set semantic is the best and gives optimal performance in such cases. List semantic depends on the index in the collection. So do you see that little star for list semantic and removal? Because it would work like this, if at all. With Hibernate in version 3.7.1, as far as I remember, you've got this. Some simple bug. So, just a curious fix. Anyway, anti-pattern is inadequate collection type on your owning side. So you need to be very careful to adjust your Java type and annotation to your usage patterns, right? You need to analyze how your collection are used and then apply the right semantic. Okay, so we've learned that set is the most efficient when it comes to addition or removal of the element from the collection. So what's the problem here? What do you think when we change this to set? And we want to add a new tree. Actually, there are two main problems. The first problem is that the entire collection must be loaded into memory because of the set semantic, Java set semantic, right? Java set semantic is to guarantee uniqueness of elements. So that's why Hibernate, when using set, must always load all the elements into memory just when you add or remove a single element. And think about other problem like transaction and lock management with version and optimistic locking. Every time you change anything in your trees, every time you apply a single tree, you lock the entire forest. Pretty stupid. When you have, especially when you have many concurrent transactions. So in such cases, when you have a lot of elements in the collection, you should switch the owning side or at least exclude the collection from locking in case if you have many concurrent transactions. Otherwise, it's not that bad for you. Okay, so we switched the side. The owning side now is on the tree side to guarantee synchronization between forest and tree. Every time we set the forest for a given tree, we also add a tree to the forest. This is pretty common pattern which you can see in Hibernate documentation. What's the problem here? What do you think? Sorry? Sorry, I don't get it.
I think that the problem is the setter method set forest.
Set forest?
Is not forest, not
Plant tree, yes. This is to synchronize, this is a common pattern to synchronize the state of objects in memory. It's common in documentation, so it should be right. The problem is in performance again, because every time you add a new tree, you must load all the trees. Why? Because we've left a set on the inverse side. And to go again, Java set semantics. So instead of set, we should use collection or list. In such cases, Hibernate will not load the entire collection into memory. So instead of set on the inverse side, use collection. So you must be very careful with owning side and your Java type and your annotations. More and more things to pay attention to, right? So is it the end of our problems? Nope. Here, what happens here? What do you think, guys? So we just, okay, we changed our set to collection, now it's very performant, and we want to remove the set. Will it succeed or not? Who thinks it will succeed? Who thinks it will not succeed? Very smart, guys. Yes, it won't succeed. A foreign key constraint. Pretty obvious. For those of you who are close to database level, what to do with such a problem? Any ideas? Nope, because we have the owning side on the tree level. So that's the problem. So you see to what problems we run to when we are trying to improve the performance of our Hibernate application. We struggle with a lot of correctness problems because we change our owning side from forest to tree, and at the moment we can't use cascade. Okay, so the only available approach, basically, okay, the simplest approach is like to null, to set our reference to null, to reset the foreign key, and then to remove the tree. But again, it means that we end up with 10,000 updates and 1 delete. So we could make it another way, like doing bulk HQL, which operates on the entire set, but it means more work for us developers, right? So another anti-pattern is one-by-one processing, sequential processing of persistent collection. And actually, that was the problem which the authors of caveat emptor wanted to avoid, but they ended up with another nasty problem. So to do such things, you should consider bulk queries. Okay, so just to sum up the presentation. Not a rocket science. Big data cause big problems for Hibernate. You need to use very smart model, bulk processing combined with projections and various more sophisticated parameters of Hibernate, like read-only queries. Also, RTFM. all those information are included in Hibernate docs. In this talk, there was nothing which was not included in the Hibernate doc. So read them carefully. And for Hibernate itself, I could think that they could work on improving the policies and implementations to help us developer even more. Thank you.
Codemotion.